ways to effectively surpass the performance of GPT-3.5 and Llama 270B. The majority of the latest extensive language models, ELMs, employ quite comparable neural structures. For example, the Falcon, Mistral, and Llama 2 models utilize a comparable mix of self-attention and MLP components. On the other hand, Mistral AI recently launched a new LLM, Mistral 8x7B, with a distinct architecture, in addition to their previously developed Mistral 7B model. This new model incorporates a sparser mixture of 8 expert models. Overall, Mistral possesses a grand total of 46.7 billion parameters. However, due to its unique architecture, Mistral 8x7B is able to operate smoothly on standard consumer hardware. In fact, the processing speed for Mistral 8x7B is notably faster compared to other models of a comparable size, and it excels in majority of tasks. This video delves into the concept of a sparse mixture of experts and its advantages in terms of inference speed compared to a traditional model. Later on, we will explore the process of utilizing and optimizing Mistral 8.7B for use on regular computing devices. A mixed sparse of experts. The sparse mixture of experts, SMOE, is a form of neural network design created to enhance the effectiveness and scalability of conventional models. The idea of a mixture of experts was first introduced to enable a model to acquire various aspects of the input space by utilizing distinct expert subnetworks. In Mistral, there are a total of 8 expert subnetworks. Please be aware that the model name 8x7B may be deceiving. Despite the name, the model actually contains 46.7B parameters, which is almost 10B less than what one would expect with 8x7B parameters. In reality, Mistral by 7B is not a 56B parameter model, as some modules, like those for self-attention, are shared among the 8 specialized subnetworks. By utilizing transformers to load and print the model's structure becomes easier to comprehend. The MemoE blocks are clearly distinct from the self-attention blocks. The duties of each specialist subnetwork involve processing a designated portion or facet of the given data, while a gating or routing network decides the degree to which each specialist influences the ultimate forecast. In Mistral, only 2 specialists are enabled concurrently. During inference, a mere 13 billion parameters are utilized, resulting in a more streamlined and effective process in comparison to similar models of identical magnitude. In conclusion, this limited activation can bring about various advantages for multiple reasons. Improving computational efficiency. By activating a subset of experts, the computational cost of evaluating the entire expert pool for each input is reduced. Efficient parameter allocation. The model can optimize its parameter usage by limiting the number of active experts for a given input. The concept of sparse activation can promote the development of specialized and detailed features in various areas of the input domain, potentially resulting in improved generalization and efficacy on a wide range of inputs. This has been demonstrated by Mistral AI's assertion that their model, Mistral, has been trained in multiple languages, including Italian, German, French, Spanish, as well as for coding. It is conceivable that Mistral AI has trained a subset of their 8 experts specifically for these languages and tasks, enhancing their capabilities in these areas. Although SMOEs are more efficient than standard models with similar dimensions, they still utilize the same amount of memory. Quantization presents an option for lowering memory usage. An alternative approach could be offloading some experts onto a slower memory source, such as the CPU RAM, especially if we have prior knowledge of which experts will be most frequently utilized for a specific task. Information on Mistral facts regarding Mistral. The Mistral model consists of 8 subnetworks functioning as experts. For every layer and token, a maximum of 2 of these subnetworks are enabled. The router network, comprising a different set of parameters, determines which subnetworks should be activated. Mistral AI provides little information regarding the training data. It is understood that the data is sourced from the web. Mistral has been pre-trained using data obtained from the publicly available web. I am curious about the concept of the open web. The model has been tested on a range of public benchmarks, showcasing Mistral's superior performance over Llama 270B and GPT-3.5 on the majority of these benchmarks. using Mixtral on your PC. The Hugging Face transformers, starting from version 4.36.0, and Bits and Bytes are both compatible with Mixtral. The model can be quantized for fine-tuning or to be used on consumer hardware. The model card from Mistral AI includes a suggested code sample for executing the model. The A100 GPU is required to run this model in a Google Colab notebook, which is only available with a Google Colab Pro membership. This specific model contains a staggering 46.7 billion parameters, each requiring 2 bytes of memory as they are in the bfloat16 format. Thus, to successfully download the model, you will need nearly 100 gigabytes of free space on your hard drive. The Safe Tensors format includes the model. It is split into 20 shards, each approximately 4.95 gigabytes in size. Upon downloading, it may take up to 7 minutes to load the model onto the GPU. When reduced to 4 bits, the model requires 23 gigabytes of VRAM. To efficiently operate it on your device, a minimum of 2 GPUs with a capacity of 16 gigabytes of VRAM each is necessary. For example, 2 NVIDIA RTX 4060 16 gigabytes, or ideally, 2 NVIDIA RTX 4080 16 gigabytes. Optimizing Mixtral on your computer. Mixtral's capabilities extend to QLoRa fine-tuning as well. Below is a snippet of code demonstrating how to load the model and set it up for fine-tuning.